Okay, hello everyone. So in this video, we're gonna try to solve this problem about continuity of a function. So let me write answers first. Okay. So the problem wants us to find the real number a plus 2b so that f is continuous on R on the whole real numbers. Okay, first remember for that in order for f to be continuous on the whole real numbers, so f must continuous only the whole numbers here, right? Because the domain is split into these three cases. So we must consider when the x, for the value of x when the f got split. So the f got split when the x is equal -1 and when the x is equal to 1, right? Because from the left, it uses this definition. From the right of -1, it uses this definition. So that's when x equals to 1 here and here, right? So say thus since f is continuous on R, f must be continuous at x -1 and x equals to 1. Because those 2 points are the only points where there are problems, right? So first, for the first case, for f to be continuous at x equals -1, remember, for f, a function to be continuous at a point, then the limit at that point must exist, right? And then that statement also mean for the this limit to be exist, then it must be unique, right? So the limit from left and the limit from right must have the same value. So we say limit when x approaches -1 from the left must have the same value as limit when x approaches -1. My bad. Wrong, right. Okay, from here we can just use the definition from here up here. So when x approaches -1 from the left, of course we use this definition, right? So sub substituting the definition of f for each side, we have this. And for when x approaches, I mean when, when x approaches -1 from the right, we use the one in the middle. Okay. let's continue on the next page. Okay, what are we going to do next is simplifying both limits. So the limit in the right side is just, there's no problem here, right? It's just a usual polynomial limit. So we can just plug in the value of -1 here. So we got a minus b minus 1, which equals to just plus b. Meanwhile, it's not that easy for the left side here, because if we plug in -1, we got 1 here. So 1 minus 1 is 0, and we have a 0 divider for the power. And we don't want that. So what do we do? Okay, here, recall that when you have a function, say f, wait, when you have a function, say f, the limit of that function is supposed to be right. Okay, limit of that f function when approaches some number, say c, is 0, and when the limit of another function, say g, when x approaches the same number, right? So when this approaches c, this also approaches c, we have either positive infinity or negative infinity. Then we have a theorem that says when these two conditions met, then we have limit when x approaches c for 1. Let me remember, 1 plus f of x being to the power of g of x. Let me shift this, shift this a bit left. This will equal to e, the Euler number, to the limit of f and it times g multiplied by g. Okay, also this, the limit is also when x, yeah, let me rewrite the whole thing, it got messed up. Then the limit of 1 plus f of x to the gx equals to a here, the Euler number, right? The power of limit x approaches c of f of x multiplied by g of x. Okay, this theorem you should have learned it from class. Okay, so we use this to solve this limit. So first we must lead this expression into something that is 1 plus a function in terms of x. So because this is x plus 2, to have some 1 plus something, we decompose it into this here, right? 1 plus x plus 1, right? This is just the same thing as the top there. And for the power, we can just rewrite it. Okay. This is when x approaches -1. from left. Okay, so now we can use, wait first, let's state our argument. Because limit of x approaches -1 from left of f. Our f here is just this x plus 1, right? It's just a usual polynomial limit. So we can just plug in -1 there. Gives us -1 plus 1, that is 0. And for g here, for this case, is here, the power, right? Okay. You might want to say this has no limit, but no, we only calculate it when it approaches from the left. From the left, you can try plugging in values that are smaller than -1, like like -1.3, -1.2, -1.1, and substitute it here. You will get something that a little greater than 1. So we have that number subtracted by 1, we get some small number, right? Let's say when it's -1.1, we square it, we have this, subtracted by 1, we have oh, this, right? And when you do it again and again, more need it something get near -1, we will have the number here will be bigger and bigger. So we can conclude it as an infinity because it's just on the left. But if we, for other case that we don't just see it from the left, this limit of this function doesn't exist. Okay, so you must see the difference. Okay, because the limit of this is 0 and from the limit of this is infinity, we can use our theorem with red text here. So the equation above becomes E lim to x limit x approaches -1 from left, and we can just see here, and wait, the f1 is this one. I got mixed up, sorry. Okay, and the right side it's just a plus b as usual, and the one there can further simplify this equation into x approaches -1 from left, x plus 1. Here we can factorize that into x plus 1 times x minus 1. So we have x plus 1 here and x plus 1 there, they cancel each other out. And now we have no problem left, right? So we can just plug in -1 into here. Remember, this negative power sign is just a notation. It doesn't mean anything. It's just mean notation. We only consider it from left. So we can, when there's no problem left, we can just plug it in as usual. We got -1 minus 1 is -2 on the bottom. So we get the power of e is -1/2. So Okay, we get this equation. Okay, next we save that and go for the next one. So I'll just copy this. For our next x case is for when x equals 1, right? So we, for f to be continuous at x equals 1, then the limit of f when x approaches 1 must exist, same as the previous case, okay? And that means the limit from the left, wait, this time it's just positive 1 from the left, and the limit from the right must have the same value. Okay, so the same logic, okay? Now, from the left of 1, we use this definition now, but from the right, we use this, okay? So let me just write that. From the left, it is, sorry, x approaches 1 from the left, it is definition of a minus b x. And from the right, we use definition of this one's log 1 cosine x minus 1 divided by x to the third right. Okay, yeah, okay. Now we just simplify this equation again, plug it in. 1 here, we get a minus b, and the one on the left, not so simple, okay? So let's see. We have x to the third and minus 1. So just like my previous video, which video was it again? My fourth video was, if I'm not wrong, we use this formula, okay? A, wait, it should be this. So the UI of Zoom is in the plus on the sign here is plus. Yeah, we use that formula for for simplifying and for factorizing that. So we get our a here is x. So we get x, and our b here is 1. 1. So a squared, 1 squared, x squared is just x. A multiplied by this x squared. Wait, just x, I mean, sorry. And 1 squared is just 1. X. And for the numerator, again here, just like my previous video, my fifth or maybe fourth video, we use the identity of double angle or cosine. When we have cos 2a, say that equals 1 minus sine square a. Yeah. So that means we have sine square a equals 1 minus cosine 2a. Here we take 2a as x minus 1. That means a is x minus 1 divided by 2. Okay, so this sine minus cosine x minus 1 is just this expression. So this one becomes, wait, there's something wrong here. There's something there. There's 2 here. Okay, there's 2 there. So this one becomes 2 sine squared, and the angle is this, because it becomes a now, just a. Okay. Wait, there's no, don't need this. Just that, right? Because 1 minus cos 2a here equals to 2 sin squared a. Okay. Next, our next step, then we rewrite this, and now from the limit here, when x approaches 1 from the right, we do it like my previous video also, my fourth video. We can just split this thing here into some multiplication. So I put 2 there, and now I put the first sign here because the sign is squared. So it's basically just itself, multiplied it by itself. And I put minus 1 there, and the last one here. No, the second sign here. You can just solve the right side here now. This is just 2. And now this, the limit of this, the limit of this thing here, you remember that from the same logic as you see when you have sine of ax to b. This will equal a divided by b, right? Well, okay. So this, I can rewrite it as, you can take new variables, say t, when I take here so when x approaches 1, t of course approaches this, and now the denominator is just t, and that thing there is just 0/2. And from the right hand side here, we have no problem into plugging in 1. So we have sine of 0 divided by 1 squared is 1, 1 plus 1 is 2, 2 minus 1 is 1. And that whole thing comes down to this. Now we can use this property. So that means it's just 1 of a half divided by 1. That means it's just a half. That last one is just 0. So the whole thing just comes down to 0. Okay, so we have the second case, we have that a plus b equals to 0. Right. Wait, I made a mistake here. This should be positive. Yeah, it should that should be a plus sign. A minor mistake. Okay, okay, no, okay, no more problem now. Okay, so from the second case, we get that equation. So wait, let me write it more elegantly. Therefore, therefore, system of equation. What system of equation, you might say? It's this. It's the two that we got from both case. So from the first case, we got this, and from the second case, we got this. Because we want f to be continuous, this system of equation must be met. Okay, let's just solve. Let's just solve this. So we get, wait, there's this one is minus sign, sorry. Minus sign there, minus sign there. So we can just solve it like usual, like you do in the middle school. I'll just add the whole thing there. It gives me 2a. So I have a is this thing here, right? And from here, we have, because a minus b is 0, we have that a equals to b. Wait, let me write it, b equals to a. And because we have found a to be this, then b must be in the same value. Let's use a simpler language here. Therefore, solving this is the system of equation. We get that a is that and b is that, so they have the same value. So for the conclusion, the problem wants us to find this a plus 2b. So now we can find a plus 2b is just this times 2 times this, this, these two cancel out. Now it's just 3 divided by 2. Okay. Okay, so that's it. So the flow is just finding the limit for each point, for the first point and for the second point. Then you will get an equation in terms of a and b for the first case and the second case. And then you just solve the equations you got, just like you solve system of equation during middle school, like usual. Then you got the value of a and b, and then it's solved, done. You get a plus 2b here. Okay, that's it for this video. I hope you understand. Thank you for watching. Bye.